let's see an example of a frequency distribution. Example, okay. On a scale of 1 to 5, how satisfied are you with your car? Okay, and just to clarify a bit, if a customer ranks a score of 1, this corresponds to would never buy again. Would never buy again. That's how dissatisfied, unsatisfied they are with the car, all the way up to a 5, which would be, let's say, want to buy one for a friend. Okay, meaning you're so incredibly satisfied that you want to spread the love and you think everybody should have this car. Want to buy one for a friend. Okay, so let's say that we had a certain number of people respond, and so maybe out of that set of people that respond, let's define X to be satisfaction score. Satisfaction score. So let's think about this. If we're going to create the frequency distribution, and the idea of a distribution is that you give all the acceptable values of a score of a variable and then list how frequently they occur, X could take on which values? X could take on the value 1, 2, 3, 4, or 5. Right? We don't allow partial satisfaction. If we did, we would give a different scale, maybe 1 to 10 or something. So here are the 5 values, and for our frequency, let's say that we had, in our survey, we had 2 people say that they were not satisfied. We had 5 people say that they were very not dissatisfied, but not that satisfied. 3 people said that they were somewhat satisfied. Let's say that 6 said that they were pretty satisfied, probably would buy another one, and let's say that 10 people said that they loved the car so much that they would, yes, buy one for themselves again, and they want to buy one for a friend. Okay, so what we've created here is called the frequency distribution. Okay, the frequency distribution shows all the values that this variable could take on. So the satisfaction score could be a value of 1, 2, 3, 4, or 5. And since it's the frequency, not just some distribution, we'll talk about maybe others later, it also shows how frequently somebody gave it a score of 1. So 2 out of the total amount gave it a score of 1, 5 out of the total amount gave it a score of 2, on and so forth. Okay, so if we look at this, if we wanted to know the total number of participants, I would say the total number n. Well, this is a sample, so I'm going to use lowercase n for sample. The total number, and I want this color, n is going to be equal to the sum of all of these values. Okay, so the sum of the frequency scores, so 2 plus 5 plus 3 plus 6 plus 10, 2 and 3, 5, 10, 26. So 26 people showed up. Okay, and we can create what's called the relative frequency. Alright, let me put another vertical bar in here. And so if I took that F value over the sample size, that would tell me the relative frequency, so the portion out of the whole of people that agreed with statement 1, statement 2, on and so forth. So for this one, we would have 2 out of 26 gave it a score of 1, 2 out of 26, 5 out of 26 gave it a score of 2, 3 out of 26 gave it a score of 3, 6 out of 26 gave it a score of 4, and 10 out of 26 gave it a score of 5. So what we're going to do is look at this data. Well, I can circle that. Okay, this data set where you have the scores, the frequency, even the relative frequency. So 2 maybe is a lot, maybe it's not, but if we compare it to the total number, then we can get this kind of size comparison of, hey, is that a lot of the people? 2? When you can compare it to, say, 2 out of 26 versus 10 out of 26. This is a lot more percentage of the people that agreed with statement 5. Okay, so this is a nice table. Often, though, we want to look at this information in a graphical form. Okay, so we have a few choices available to us. We have the histogram or the polygon, and those two choices are based on the fact that we have quantitative data here, right? So the value of x, so the variable that we're looking at, those are measured on, well, an ordinal scale, kind of, because we're ranking, but it's not first, second, third. Okay, we're just putting a kind of interval value to it. We're saying that this, if number 1 corresponds, so it's kind of a nominal scale, but since it's a number, we're going to say that it's more like the interval scale. There's no absolute 0, so it's definitely not the ratio. So because it's a quantitative value, we can put it on a histogram, or a polygon graph. Okay. If it was categorical, so maybe I'm looking at colors and people's preferences in color, so if I asked, hey, what's your favorite color, and I said 2 people said blue, 5 people said red, 3 people said yellow, 6 people said green, and 10 people said orange, then X over here, these would be categorical variables. They would be listed out on a nominal scale, and we couldn't use these graphs. We'd have to use something called a bar chart. Okay, it's very similar to histogram, but there are differences. So this is definitely for the nominal scale. Sometimes we'll use it for the ordinal scale, and that's it though. Okay, so let's take a look at creating a histogram by hand and a polygon, and I hope to give you enough difference between them so you can understand. Okay, so our data set, we had, for our x values, we had 1, 2, 3, 4, and 5. For the frequencies, we had 2, 5, 3, 6, and 10. Alright, so I'm going to try really hard to make a good graph here. It might be tough. This line, and let's do it in white. Let's give it a vertical line and a horizontal line. Alright, so on the horizontal, we are going to use put the x values, and on the vertical we're going to put the frequencies. Okay, and so the ordered pairs, we're gonna plot some points based on these ordered pairs. So this is the ordered pair: 1, 2, 2, 5, 3, 3, 4, 6, and 5, 10. Oops, 10. Okay, so up here at 1, 2, 3, 4, 5, and on the vertical, let's just go by 2, 2, 4, 6, 8, 10, and that's 10, and that's 8, 6, 2, 1, 2, 3, 4, 5. Okay, so here we're going to do, and I'll do this in blue, whatever color this is. I'm going to do the polygon graph. It's not blue, is it? Alright, so this is going to work by just plotting the points. So we have 2 people said the value 1. We have, for the value 2, we have 5 people, so we're up here. For the value 3, we had 3 people, so we're in there. Value 4, we had 6 people, all the way up here. And for the value 5, we had all the way up here at 10. Okay, so a polygon, meaning just that shape, we're going to connect these with lines. Let's actually do it with a straight line and keep that color. Yeah, so connecting these dots, there we go, there we go, here we go, and up. So we get a quick kind of visual snapshot of what's going on, and this graph here is called a polygon graph, and it graphically represents this data in yellow. Alright, so I probably should put a title on this. Let's call this graph the distribution of, so this will be satisfaction scores. Okay, and it's a visual interpretation of this data set in yellow. Okay, what's nice about it is that it quickly tells us that just by looking at this graph, it says that we see that it's kind of got this upward trend, and so we're seeing that it appears that more people are satisfied than not satisfied. And just comparing the scores here, 5, there's more people that agree with 5 than any of the other ones. 3 and 1 were the low scores. 1 is definitely the low. So I would say overall people are satisfied with the product. Okay, we can also create, and let's do this in green, we can also create what's called a histogram. By the way, I'm colorblind, so I might be calling out colors that aren't real. I don't know, I think this is green, I think this is blue, but it could be purple, it could be turquoise, and I wouldn't be able to tell you that. Anyway, so okay, a histogram. A histogram, what we're going to do is very similar in the sense of creating a kind of height statement for the frequency, but instead of having a dot, what we're going to do is split the distance between our numbers. So between 1 and 2 we have 1.5, between 0 and 1 we have half, 2.5, 3.5, 4.5, and 5.5. And what we're going to do is we're going to draw rectangles starting from that halfway mark to the next halfway mark, and the height of that rectangle is going to be the frequency. Okay, and so in other words, we want to center the value. For this case 1, we're going to center that in the middle of this rectangle that has height 2. So here's the rectangle, and then for the value 2, we're going to straddle again a rectangle that's centered on 2, and we're going to go up to a height of 5. See my very poor artistic skills. For 3, there are 3 scores, and so we're going to do this. Okay, and then for the value 4, there are 6 scores, so put that in, down, and for 5, there are all the way up here at 10 scores. Alright, so a lot of times we'll shade this in, so I'll just rough that shading in. This is how I would do it on paper anyway, so I'm just sketching it by hand. Alright, what's nice about the histogram is if this were truly a value, so if x was a variable that was coming from the ratio, the scale of measurement was the ratio, what the histogram will do is it puts in the real limits. So this lower bound here for 1, for example, is the lower real limit, and this 1.5 is the upper real limit. Okay, so in other words, this shows how people would round. So if somebody was kind of split between a score of 1 and 2, and it's like, you know, I'm not halfway in between 1 and 2, I'm a little bit closer to 1, so I'm going to round down. Okay, so if somebody was, you know, having a hard time ranking their satisfaction with their car, and they're like, I'm not sure if I'm a 1 or a 2, well, some of them are going to round down, some of them are going to round up, and so the histogram will capture that kind of approximate rounding issue. Not that we're actually talking about people rounding because you have to choose 1 or 2, but you could be in the middle and you kind of decide to go one way or the other. And so having these lower and upper real limits, it allows us to kind of capture that possibility. Okay. The other nice thing about a histogram is it gives you a better sense of the overall shape of the graph, and we're going to talk about shape of the graph in a later video corresponding with the material in chapter 3.